Hello everyone, I am Fasir Rahman Qureshi.
And I'm Yuhan Xiang. We are excited to present our machine learning project titled Dataset Engagement Prediction, developed for the MetaTab Kaggle hackathon.
All the code, notebook, and reports are publicly available on GitHub as well as on Kaggle.
Kaggle is the world's largest platform for data science competitions and datasets. Every day, hundreds of new datasets are uploaded, but not all of them gain attention.
Some datasets get thousands of views, downloads, and community comments, while many others receive very little engagement. That led us to ask our central research question: which datasets lead to higher engagement on Kaggle in terms of views, votes, and forum discussions?
To answer this, we used Kaggle's own metadata, the Kaggle datasets, and built modules to analyze trends and predict engagement levels using dataset features.
For data preparation step, we use three core tables of MetaKaggle that are datasets CSV, forums.csv, and forums topics.csv. Datasets.csv has over 500,000 records, and forums.csv links each dataset to a forum. And forum topics.csv contains discussion threads.
Since Kaggle doesn't provide direct comments counts, we created a new feature, Total Forum Topics. The number of discussion threads per dataset, acting as a proxy for comments.
After merging and cleaning, we had a well-structured dataset with columns for views, votes, downloads, forum discussion, and other metadata like user IDs and update dates.
And as for the EDA, our first observation was the engagement metrics are highly skewed. Most datasets get low interaction, while a few go viral.
To handle this, we had applied logarithm transformation to our target variables. This helped us normalize the distribution for better modeling.
Next, we explored relationships. We found strong positive correlationships between downloads and views. It shows 0.89, and between the downloads and votes, it shows 0.53. And as for the forum topics and votes, it shows 0.84.
On the other hand, IDs like owner user ID or data version ID had no predictive value, just noise.
And as for the data preprocessing, we have dropped some columns with more than 50% missing values, like owner organization ID and medal award date. And we also dropped columns with no variation, like type and some features like irrelevant identifiers like ID.
We then added a new feature called activation activity duration, which is equal to last activity date minus creation date. It gave us measure of how long a data set was active. We also filtered outliers like by using the IQR rule and split the data into 70% of training data set and 10% into validation data set and 20% into test data set.
And as for the modeling approach, since we had three target variables, views, votes, and forum topics, we use a multi-output regressor from scikit-learn to train multi-target modules.
We tested three models: ridge regression, which was fast and interpretable, XGBoost regressor, which was powerful and robust, and neural network, a simple two-layer dense model with early stoppings.
Instead of grid search, we use adaptive hyperparameter tuning. Each module refined its key parameters like alpha or n estimators based on validation MSE.
Here are our final results on the test set. A model like Ridge gave us average MSE of 0.2548 and average R square of 0.68, XG Boost average MSE of 0.1635 and average R square 0.7571, neural network 0.1788, and average R square of neural network was 0.4053. Uh, yeah.
XGBoost outperformed the others, especially on datasets with mediums to high engagement.
So what did we learn? Engagement is not random. It's strongly influenced by downloads, kernel counts, activity durations, and sometimes medal status.
Our proxy metric total forum topics also worked well as an engagement indicator, despite not counting replies or sentiment.
Still, our model had some limitations as well. No text analysis on titles on or tags couldn't capture temporal spikes and external promotions. Heavily skewed data made it harder to predict low engagement datasets.
After the module training, we have some future works we'd love to do. First, we will use NLP to analyze titles, tags, and descriptions, and build time series modules for engagement trends. And then we will check users' behaviors. Do high reputation users get more visibly?
These additions could improve Kaggle's dataset recommendation system, help new creators, and make engagement more predictable.
To summarize, we answered the question which datasets lead to higher engagement on Kaggle.
By analyzing over 500,000 datasets and training machine learning model, we showed that downloads, kernels, and activity durations are key predictors, and that metadata alone can estimate a dataset's popularity fairly well.
Thank you for watching our presentation.
And once again, you can view our code notebook and report on GitHub and Kaggle as well.
We hope you find it insightful and we welcome your feedback.
Thank you. Bye.